Hey everybody, hope everyone's doing well. This is Anish back at you. So, we are in our final week of our 7 week, 7 app challenge, and this is super, super exciting for me and hopefully for all of you as well. And the app that I'm making this week, as I told yesterday or introduced yesterday, is something that can help to track your family and your loved ones, and possibly your kid who's taking the school bus from the school back home, and the tracker for the school bus does not work. So this is an application which I'm really hoping at the end of the day there's a hardware component to this as well, where you get a satellite SIM and put it on a tracker. And I'll show you how to use IoT Core or just do a simulation, and how to connect IoT Core to the Lambda function. And hopefully you can all build something that can keep your loved ones safe, and hopefully have this tracker, let's say, sewn into the bag of your kid that's maybe going to first grade or whatever. Okay. And so this architecture I'm going to be using is exactly the same as what I started with. So we went really up on all our applications, went to Kubernetes, and last time did everything with Cognito. So we went through a lot of hoops, and we also went into a machine learning training model last time, which was kind of a success, but not really. And so this time it's a straightforward architecture. Lambda to API gateway. I'm not even going to use DynamoDB and getting an answer from Bedrock. I'm going to connect it to the Google Maps API to get the locations. And finally, I'm also going to connect to the weather API, a free weather API, so that I also get the weather around where the your loved ones are. And so using that, we'll get our final outcome. So let's start with the Lambda function. So this is a track location Lambda function. I needed a few layers that I added. If I do use a database, if it's going to be an RDS database, I'm going to end up using the MySQL connector. I'm also using the Polars package and the request package. So these are the different layers that I'm getting. And as I've told before, if you are ever interested in getting the layers, there is a, a K layers package on GitHub that you can actually go ahead and choose your region and choose the ARNs for your particular Python version. For example, if you're going to Python 3.10, I am in US East 2. You can get a JSON here, and it's not for all packages, but for the important packages. So here, for example, requests, I can get this particular ARN and put it in my layers. So this is just a tip for all of you. Now let's go ahead and look at this particular code. So here, the first thing I'm going to do is also instantiate an SNS client, because at the end of the day, I want to ask a question. Hey, where is I don't know, Bailey? Okay, and so the answer wants to be in an empathetic format, and ultimately, I want to send the actual location as a SMS to um, the loved one that's at home, or they also are on the road or whatever it is. And so for this particular demo, I'm going to mark the coordinates, meaning your loved one is in Seattle or San Francisco or New York or Los Angeles, and these coordinates are going to come live from IoT Core. I do a little bit of course handling, and then parsing the incoming request. So what the two things I'm going to get are, the first thing is the prompt, which is the user input, or part of the prompt, which is going to be the user input that's going to come, which is a question. Hey, I'm worried. Where is my daughter, or something like that, and phone number, because at the end of the day, I want to send an SMS. And then I'm going to choose a random coordinates from the mock coordinates. The kid's name is Bailey, and Bailey's lat long is going to be defined by this, and Bailey's address, I'll define this function, get the address from lat long. Now I'm also going to compute a distance, which is going to be an approximation with what's called as the Haversine distance. So if you're interested, the Wikipedia article for this is pretty good. But the real difference between just a regular velocity and a time speed, I'm sorry, velocity and the time that you estimate, if you're going to compute the distance, that does not take into account the Earth's curvature. And so that's the difference in the Haverson formula that takes into account the Earth's curvature and has these kind of arc sine functions and all of that. So maybe take a look at that. And then finally, I'm going to get the weather context. So basically, the three things: get the address on exactly where the location is, how much distance it is, and I assume a velocity that is going to be, I think it's 40 kilometers an hour for the bus actually. So the whole use case was someone taking the bus or maybe driving and having a steady velocity. And so the prompt is going to be Bailey is currently near the Bailey address. She's approximately ETA from home. And this is the weather. Answer the user's query. So user is where is Bailey based on context. Do not repeat statement. Avoid saying location not available. Instead, describe it as an area near Seattle or by the coordinates. And respond warmly and empathetically addressing the user concern and a few more things. And I'm going to be using the Claude 3.7. Hopefully, I have this has been mentioned multiple times, but this comes from cross-region inference on Bedrock, and we do a few things with codes and everything, and then here we define the Haversine distance, and then we are going to get the distance in kilometers. Again, I'm going to assume a standard velocity. And once I get the distance, I'm going to compute the time taken. So the average speed I'm going to assume is 40 kilometers an hour. So I have the Haversine distance, I have the average speed. I can compute the estimated time to arrival in minutes. And then I get the weather context. So I get the weather API key and parse it out a little bit, and I'm going to get the address from lat long. Again, I get the Google Maps API keys with the Places API and the JavaScript API. Also enable a few other APIs if I want to use them in the future. And then I just parse the URL. And with the key and the lat long, I can just go to maps.googleapis.com and it'll give me the actual location. And then finally, if I'm ready for this, I said that I had some problems with support on getting the production SNS client. And so this I'm never able to show you all, but hopefully if I do turn this into a production application, I will end up doing the SMS as well. All right, so very simple code, and it's week 7, so I wanted to relax a little bit, but it's a good application in terms of what I'm trying to achieve. And so this is already deployed. And what I'm going to do is I'm going to go to test. And here, for example, I have a sample test written somewhere. Let me get that. So I'm going back to the code and making sure that I understand what the test should look like. And and then really I'm just asking ChatGPT for this. And so you can see that the test comes up something like this. So that's a post, and then I'm going to ask where is Bailey and when will she be home? I am worried, something like this, and then the phone number something 2065550 And so let's go ahead and test this outcome. So it takes a little bit of time because it has to hit Bedrock. Cloud has to come back. It has to hit a couple of APIs. But ultimately, it comes back with the Bailey is currently near downtown Los Angeles, specifically around 106 West. She's experiencing partly cloudy weather with a comfortable temperature of 18.3. I understand your concern. She's approximately, I'm assuming I'm in Seattle, away from home, which is quite a significant journey. This area is in the civic center of Los Angeles, near landmarks. Please do not worry too much. Would you like suggest ways to contact her directly? Given travel time, she may be returning a long distance transportation method rather than driving it straight through. And it also gives me the Google Maps location on where Bailey is. So if you actually go in here, boom, this is hopefully this is downtown Los Angeles. Looks like it. There's Griffith Observatory. Okay, so this is again a simulated result, but ultimately this is what I want to get to. And I think I'm going to build a web app or a mobile app. I'm not really sure, but again, I'm going to be using Kilo to build this. And ultimately we'll be able to show this message, give this, and then the SNS, if I get into production, we can send SNS as well. And finally, I just wanted to show you, if you really had the full energy and wanted to build a tracker, what you can do is integrate IoT code to the Lambda function, which can send real-time coordinates, and then you can connect a device. Okay, so it's a pretty straightforward. Make sure it's connected to the internet, and then load the device and do a few things. Okay. So with that, that's all I have for today, everyone. And tomorrow I'll go ahead and show you the API gateway, and finally on the last day I'll just show the front end or the mobile app to get the final outcome. So with that, hopefully you are all excited for this week 7, and I will see you all tomorrow. Have a great day, everyone.